Welcome back, everyone. Today we're going to zero in on one of the most critical parts of managing Cisco ACI, the fabric-wide system settings. Now, these are not just some random checkboxes in the UI. Oh no, they are the fundamental policies that really define the behavior, the security, and the stability of your entire network fabric. Getting these right is absolutely key, so let's just dive right in.
So here's what we're going to cover. We'll start with the basics. What are these settings and where do you even find them? Then we'll get into the nitty-gritty of the core validation policies. Think of these as the security guards for your fabric. After that, we'll explore the active endpoint controls, which are kind of like a real-time immune system. And of course, we'll wrap it all up with Cisco's recommended best practices.
So, what are we really talking about here? Well, fabric-wide system settings are a group of global policies. Once you set them up on the APIC, they get pushed down to every single leaf switch that joins the fabric. This makes sure every switch is playing by the same rules, giving you consistent behavior across the board right from day one. It's a truly foundational step.
And where do you find this magical panel? You'll just navigate to System, then System Settings. It's basically a central hub for a bunch of otherwise unrelated but super important fabric policies. Getting these settings configured correctly from the very start is, and I can't stress this enough, absolutely crucial for building a stable and resilient ACI fabric. All right, let's look at our first group of settings, the core validation policies. The best way to think about these is as the fundamental rules that keep your fabric clean and secure. They're like the walls of your castle, preventing common mistakes and potential security holes before they can ever cause a problem.
First up is remote endpoint learning. Now, the setting is actually called Disable Remote EP Learning, which is a little confusing, and you'll see it's checked by default. And that's on purpose. It forces your border leaves to learn about remote IP endpoints only from the spine's proxy database. Why? Because this gives you a single, consistent, authoritative source of truth for where everything is. There's a small exception from multicast on some newer switches, but for your day-to-day traffic, this setting provides the stable, predictable behavior you really want.
Next up, we've got Enforce Subnet Check. This one is incredibly powerful. Just picture this. A server or a VM comes online, but it's been misconfigured with an IP address that doesn't belong to its network segment. Without this check, ACI might just learn that wrong IP and poof, you're black-holing traffic and you've got a huge headache on your hands. This feature just tells the fabric, hey, if an endpoint's IP doesn't belong to a subnet that's actually configured for its VRF, just don't learn it. Simple, right? But so effective.
And turning it on is as easy as checking a box. I absolutely agree with the recommendation here. You should for sure enable this. It's literally one click that gives you a massive boost to your fabric's IP address hygiene and overall stability.
So why is this one so important? Well, for starters, it's a basic security measure against IP spoofing. It also contains the blast radius of simple human error, preventing one misconfigured server from taking down the whole network. And finally, it basically hard-codes your IP address management plan right into the data plane, making sure the fabric operates exactly the way you designed it.
Okay, let's talk about Enforced Domain Validation. In ACI, domains are how we connect our application groups, our EPGs, to the real world, usually through VLANs. This setting makes sure that an EPG can only use VLANs from a domain that it's supposed to. It's a really important link in the whole policy enforcement chain.
This is a huge deal when we think about role-based access control. See, in a lot of ACI setups, you have an infrastructure admin who sets up all the physical and virtual domains, and then you have tenant admins who configure their apps. This setting stops a tenant admin, whether by accident or on purpose, from assigning an EPG to a VLAN they haven't been given permission to use. It's a key feature, especially for multi-tenant environments.
This next one, validating overlapping VLANs, it solves a very specific but very, very nasty problem. Let's say you accidentally assign two different VLAN pools to the same EPG, and whoops, those pools have some of the same VLAN IDs. Without this check, different leaf switches might end up assigning different internal IDs for the exact same EPG. And that leads to total chaos.
And the consequences are no joke. We're talking about endpoint manager sync failures between VPC peers, which causes this maddening intermittent connectivity for every single endpoint in that group. It can even cause bridging loops. Seriously, enabling this global check is a non-negotiable best practice. It prevents these nightmare to troubleshoot issues by simply not allowing the bad configuration in the first place.
Okay, so we've built our walls with the validation policies. Now let's talk about the fabric's immune system, the active endpoint controls.
These are the dynamic policies that are always watching endpoint behavior in real time, ready to take action to protect the network from instability or even an attack.
First in this group is the IP aging policy. See, normally an IP is tied to a MAC address, and it only gets cleared from the endpoint table when that MAC ages out. But what if the IP isn't being used anymore, but the server's MAC is still active? This feature solves that. When you turn it on, the fabric actively sends out probes to check if an IP is still alive. If it gets no response, it just ages out that IP, keeping your endpoint table nice and clean. And as you can probably guess, Cisco highly recommends turning this on. Now for something really cool: rogue endpoint control. So what exactly is a rogue endpoint? It's a device that looks like it's moving around the fabric at an impossible speed, flopping between different ports, different EPGs. This could be a malicious attack trying to mess with your endpoint table, or it could just be a simple misconfiguration. Either way, this feature detects that crazy movement and puts the offending endpoint in quarantine, effectively neutralizing the threat. And you get to control exactly how it behaves. You can tune the detection interval, that's the time window for watching. You can set the detection factor, how many moves it takes to set off the alarm, which is 4 by default, and you can configure the hold interval, which is how long the endpoint stays in quarantine. The default is 1800 seconds or 30 minutes. Now, related to rogue endpoint control, but a bit different, is endpoint loop protection. This one is laser-focused on a classic network nightmare, a loop. When a loop happens, endpoints can look like they're flapping back and forth really fast between two specific ports. This feature is designed to spot that exact signature and take action right away. The key decision you have to make here is what action you want it to take. When a loop is detected, you can have ACI do something drastic, like disable one of the ports involved to break the loop instantly. Or you can choose a less disruptive option, BD Learn Disable, which just stops learning on that bridge domain but keeps the port up and running. The parameters here are going to look really familiar. You've got a detection interval, 60 seconds by default, and a detection factor, 4 moves by default, plus that critical choice of action. The key difference, and let's be super clear on this, is that this is targeting flapping between just a pair of ports. Rogue endpoint control is looking for much wider, more chaotic movement across many ports.
Woof! We've covered a ton of ground. So let's bring it all together into a clear, actionable blueprint. This is the summary of best practices you can use to guide your own ACI fabric setup.
Okay, let's just walk through these recommendations. For remote endpoint learning, the best practice is basically to leave it alone at its default, disabled, to keep things predictable. For enforced subnet check, domain validation, and validating overlapping VLANs, the guidance is crystal clear. It is always a best practice to turn them on. For IP aging, the recommendation is to enable it and just use the default timers unless you've got a really specific reason not to. And that brings us to our final two, which have an interesting relationship. So let's put these side by side, because this distinction is really critical. Rogue endpoint control is built for broad instability, an endpoint jumping all over the place. Its action? Quarantine the endpoint itself. Endpoint loop protection, on the other hand, is for a specific loop between two ports, and its action is to disable the port or stop learning. But here's the key takeaway from Cisco. Generally, you should enable rogue endpoint control instead of endpoint loop protection. Why? Because it often catches the same problems while being a little less aggressive. It's a subtle but very important choice.
You know, at the end of the day, mastering these settings is about more than just a one-time setup. It's really about adopting a mindset. Proper configuration is the ongoing practice of building and maintaining a network fabric that is stable by design, secure by default, and resilient against both human error and whatever else gets thrown at it.
So these settings, they really lay the foundation. They are your first and your best line of defense, but they're just the beginning. And this brings us to a final question for you to think about. Now that your fabric is configured for stability, what ACI monitoring tools and operational practices are you going to use to proactively validate its ongoing health?